This PowerPoint I just did this weekend, so it's not going to be up on the laptop. I'll try to get it up there this afternoon. But this deals with lockout, tagout. Or lockout, tagout, the same thing. So we could have a tag without a lock, but we can't have a lock without a tag, right? And this basically deals with the procedure for lockout, tagout. So it says about 150 people died because there was a failure to control energy in the workplace. Deaths could have been avoided. Workers could take time to perform lockout, tagout. And of course, it says a lack of respect for hazardous energy could cost you your life or your co-worker's life, right? There's been several. I think I told you about the guy that. Did I tell you about the guy that got killed on top of number 8 blast furnace? They had a problem with the hoppers up there. And, he cut in half, yeah. Yeah, he was, they had locked, it had, number 8 blast furnace, it was pressurized, so what they did is they had belts that fed the material up to the top of the furnace. And then they had a hopper that opened in the top, and then that hopper would close, and then a hopper in the bottom would open and drop it into the furnace. And they was having a problem with one of the hoppers up in the top. They locked it out, they tagged it out. He was up there working, and he told them to push it in so he could watch something work after he disconnected everything. And the guy went down there and pushed it in the wrong relay. And the bottom hopper opened, and it cut him in two. So, just about most of your manual devices have what we call a mechanical or has an override on it. So if it's controlled electrically and it's a manual device, then what we can do is we can override that, and you can understand why they want that, because your computer goes down or your PLC catches on fire and you've got a furnace out there that's full of steel, and you need to dump it somehow, right? You understand? You need to have overrides. So we'll look at our the relays that we have over, especially on the Amtrak line. Every one of them has a manual override. Even the even though the directional control valves for our pneumatics has overrides. Some are easy to get to, which is a shame, and some of them you have to deliberately get to. So a lot of your relays are really, really easy to get to. Okay, the purpose of lockout, tagout procedure is, of course, preventing death result of acting over energy. Everyone in the workplace needs to know about lockout, tagout, right? Whether they're responsible for the locks or tags. Everybody knows what a lock is. This doesn't cover some things that are required. First of all, the lock, we cannot use a combination lock. And why is that? Yeah, combinations get out, right? You understand that? So it has to be a key to lock. And the procedure has changed since I was out at US Steel. When I was out there, we had 2 keys. And the supervisor had 1 key and you had the other. And they kept it locked in a lock cabinet. So only the supervisors had a key to the cabinet that had the lock star locks. And then that way, if they couldn't get in contact with us, then they had the ability to unlock it. I think the procedure out there now is there's only 1 key to a lock. So if you're out and you're not there and you leave your lock on there and they got to get it off and they got to go through a procedure. What was the procedure? First of all, they had to verify that you wasn't inside the plant, right? You had to try to call you. Yeah, right. And then if they didn't get in touch with you, they'd try to go out there and verify that taking it off was okay, and then if it was, they would cut it off eventually. lock is most often placed on the machine. You turn it off and prevent it from starting. A lock prevents switches from being activated or valves from being turned on. Locks are most often used when the machine needs maintenance and repair. So normally when we troubleshoot the equipment, we do it with power on, right? You can't fix something if you can't make measurements and see if your pressure is there and all that other kind of stuff. So what we'll do is anytime we move the line or tear the line apart or we replace a part or do any type of maintenance on our manufacturing line, what are we going to do? We're going to lock and tag, right? Everybody okay? And everybody knows what a tag is a card or piece of paper. Usually it's got a rag on it. Most of the tags you'll see used, it's got the paper tags has got Tagout on it. And then what information do you need to put on that? You need the tags usually indicate the place, who placed the tag, the date it was placed, the names of the workers involved, the supervisor's name. I don't ever remember, at US Steel we didn't put the supervisor's name on there, and why? Because they changed, right? We had different people, different shifts. When I was out there, some of the supervisors actually rotated just like we did. So, tags worn machine or equipment has been de-energized so work can be safely performed. So all the tag does is convey just information, right? You understand? Sometimes a tag is all we have. So over in the pneumatic lab, there is no way to lock out the disconnects. So what do? We turn them off and put a watt on there. Put a tag, right? You understand that? No, you got to put every person has to have a tag. You cannot take anybody else's lock off. Because what if I go out there and I'm the person and that's my tag and I take that lock on and we got 6 other locks on there with no tags. So everybody has to have the tag. Every lock has to have a tag on it who it belongs to. Why did y'all used to do that? Huh? And you can understand that, why, right? You understand. So, many employees are killed and injured each year when they're working on machinery or power attacks and stores. If the proper lockout tagout procedure was followed, then that couldn't happen, right? You understand that? This says that a worker is instructed to clean asphalt mixing machine while he is in the process of changing the paddles. Another worker bumps the switch and makes the door close. We had one just happened in Alabama, and I forgot what it was, but it was some type of meat grinder, and the guy was in there cleaning. And what? Nobody knew he was in there. He's inside this thing cleaning this thing that's so big, and what did somebody do? Turned it on, yeah. It was an oven's what it was. Yeah. It could be you. Every workplace has some form of energy, right? You understand, or some power source. Our manufacturing lines have 2 power sources here. And of course we use 3 main power sources. What are the 3 main power sources? Well, mechanical. Fluid power. Now, fluid power involves either hydraulic or pneumatic, right? You understand? And electric. So those are the 3 types of power sources that we move through, right? You understand? So you could be a power source. So you go out there on a mechanical thing and you could be turning a crane, right? You understand? Which could be doing something bad. Energy comes from many forms. Most common energy is electrical, chemical, thermal, hydraulic, and mechanical. So these are energy. So when machines or equipment need to be serviced and maintained, the energy must be isolated so authorized personnel can safely perform their work. Who's an authorized? What is an authorized person? It's just, well, maybe not certified, but it's just somebody that's been trained to operate the equipment. They understand how the equipment operates and where the energy sources are. Of course, the goal for lockout tagout procedures is protect workers. Another goal is to prevent energy from accidents from machines and equipment are being maintained in service, and that maintained in service. So maintenance, anytime we're doing maintenance on the machine, and that's not true. There are some extenuating circumstances where we work on we do live work, right? We actually repair on live stuff. Line crew, Alabama Power, they do it all the time but you have to justify. Is it more dangerous to work on it off than it is to do what? Work on it on, right? Understand? There's a lot of life support equipment and stuff out there that depends on electricity. Yeah. And there's some things you cannot turn off, and there's some things that you can't turn off. So that's when your tags and stuff else would come into play, right? Unlike small appliances, hand tool adjustment machine requires more than what? That's on Tuesday, Thursday night. $226 is cable splicing and installation. I teach that. I don't know what Sanders is. You know. Well, he teaches on both campuses. It's kind of strange. Unlike small appliances, it does still require more turning off, more than just turning it off, switch or unplugging the cord. These machines get their power from multiple energy sources to interact with each other. If all energy sources are not isolated before service, they're making perform an activity for each energy to occur. So that means if you've got multiple power sources, what are you supposed to do? You're supposed to lock and tag every one of them, right? Everybody understand that? And so usually when you got an industry, they got locks and tags on everything. What do you mean? Yeah, that's part of and this hadn't popped up yet. That's a common mistake, and it's going to be in these PowerPoints. Is that even though you cut the energy off, you're supposed to verify that it's gone, right? I understand that. A lot of our electrically activated disconnects depends on blades and this kind of stuff, and those things can get stuck, right? You have to do it with you have to do it with a meter or some other source. And electricity, of course, the meter is what we would do. So what we would do every time we lock out the electrical, we would do what? We would test it. Pneumatics. Pneumatics or hydraulics. The problem with pneumatics, what is the problem with pneumatics? Even if I lock and tag out the compressor, what's the problem with it? Yeah, that guy has stored energy. So even inside your piping, so if you lock and tag in your piping inside your system, it's going to store energy. Hydraulics, when you kill the pump, you kill the energy, but the problem is that some systems run these things we call accumulators. These are big old tanks out there that's got either springs in them, or they got big weights, or they use pneumatic pressure or gas pressure. And what happens is this allows us to build a system or use a pump that can handle the average demand, but it can't handle the maximum demand. So what it happens is when you turn that thing up, it fills up that big old accumulator. And then when it needs the demand, then the accumulator supplies it, right? You understand? These are pretty popular on the people that have the water pipes that sing and stuff like that, they'll put these accumulators on there. And that's what it does. It holds pressure and tries to maintain pressure. So accumulators on a hydraulic system smooths out the system. So even though the demand is changing, anytime the pump can't maintain the flow, then it can get that flow out of the accumulator. So we have to make sure those things are drained or disconnected and that kind of stuff, right? You understand? But what's nice about our disconnects on our pneumatics on the Amatro line is and you need to verify that it's gone, right? You understand? A lot of pneumatic systems will have a valve out there you can turn and bleed it off, right? You understand that? Now, you don't have to necessarily lock out your compressor. You just got to disconnect it from the machine that you're working on, right? You understand that? We got to lock it. I don't know where it's at. We moved it, but we've got. We can go over there and look at the big FANUC robot in a minute and look at the lockout. They lock out everything, right? So we'll see that. Okay. Lockout tagout procedures. Lockout procedures may only be performed by authorized employees. Of course, we know who that is, right? Who have received proper training. Authorized employees are trained to recognize the types of hazard injury sources in the workplace and know how to isolate and control that energy. Everybody okay there? 7 steps. Here's the 7 simple steps for lockout. And this came right off OSHA's site. Step 1, proper planning. Step 2, notification to all personnel, shutting down and operating controls, isolation of all energy sources, lockout, tagout of isolated devices, release all stored and residual energy, and verification of isolation energy. And that's what you brought up a while ago, Dwayne. We don't just lock it out, we verify that the energy level is gone, right? A lot of your pneumatic systems and your pressure systems, they put pressure gauges out there. So when you disconnect it, you can verify with the gauge that the pressure is gone. All right, you understand? And then, of course, there's only one real way you can verify that the pressure is off the machine instead of trying to operate it. You know, and that's not be a good idea too, right? Is to go out there and check it, especially if you're dealing with multi-phase systems, because you could go in there and hit a button and one phase might still be stuck on, you know, and that could, so the machines might not run because they don't have enough energy to run, but still there's enough energy out there to kill you if you get into it. So we go out there on electricity, we just get our meter out and verify that the meter is down. You're supposed to have a meter in this class. Everybody got their meter? Huh?
Got one. Got it. Yeah. I get the last.
Oh, I'm sorry. They go through every one of them again. They go into it a little more detail. So lockout tagout doesn't actually occur until the lock. Step 5. So you can't lock it. It's just like the disconnects on the Amatro line. You can lock it on too. So if you put the lock on in step 4, you're going to lock it on, right? Are we okay? When my little 9-year-old granddaughter was over here last weekend, and we were playing around. I was showing the stuff, and she locked it out with it on. Proper training is the key. I just play with all the locks. Proper training is the key to success on lockout tagout. Authorized personnel must consult with written procedures or proper personnel to determine the type of magnitude of injury involved. Of course, we already talked about that. Both our manufacturing lines are off 120 volts AC or thereabouts, and both of them have pneumatics for their secondary power source. But you'll run into industry where they might have all mechanical, they might have electrical, they might have pneumatic, and they might have fluid power, all of them. And what you're supposed to do is lock out every one of those sources, if you can. Are we okay? Proper planning helps authorize personnel answer important questions about the system to be worked on. What equipment is needed besides lock? Are there any hazardous substances that need to be drained? Should protective equipment be worn? Should the industry accumulate again while working being performed? How many locks are needed for the job? So we'll need 2 locks on our Amtro system. The Festo system, I need to go find our lockout tagout kit. The Festo system does not have locks on the front. So what we would have to do is we'd lock it out using other means of lockout on that one when we finally get to work on that one. The Amtro line gives us the ability to lock out.
The key factor in telling you when you need to do what.
If you're going to work on it, you lock it tag. If you're going to troubleshoot on it, then we don't lock it. That makes sense. If you're going to get out there and get your hands in that thing, then we need to lock it tag. So anytime you replace parts, even a lot of times we do preventive maintenance on a piece of equipment, like greasing and stuff like that. So our robots, we're supposed to grease the robot. So you're out there on that robot and you're greasing it, and it's a big robot, then you need to do lock and tag, unless they come up with another method of preventing that thing from moving.
On the troubleshoot part, that mainly comes to lock PLC.
Well, it all depends. Everything's different. You know, everything's different. So it depends on what you're doing and where the problem exists. I'm not saying they don't, but PLCs very seldom go bad on them. They do, but very seldom. So usually it's out in the system that you're actually troubleshooting. PLCs are real nice to use as a troubleshooting aid because of the lights and stuff they have available on them. So you can verify, if you got input problems, you can verify if the input is getting to the PLC by doing what? Looking at the PLC. Also, it's becoming very, very popular for your sensors to put indicator lights on them also. So a lot of the electronic sensors that we have indicator lights on them when what they check for is true or false. And that's becoming very, very popular also. But PLC is a good troubleshooting tool. The problem is the PLC is usually over here, and your problem is what? Over there. So even if you don't get an input on the PLC, you're eventually going to have to go out to that line and replace a sensor or something like that, or find a broke wire or something like that. And that's kind of, so looking at the PLC is troubleshooting, right? When you go out there and replace a sensor, or when you go out there and check a wire, or when you go out there and do something like that, replace conductors, then that's maintenance. So lockout tagout is when you're out there actually doing what? When you're actually working on the equipment. Not troubleshooting, doing what? Working. Notify all affected personnel. So you're supposed to tell everybody that's around there, I'm fixing to lock this thing out. I'm fixing to cut this thing off. Let them know what's going on. It's always nice if everybody knows what's going on. Everybody okay? What if they're using LO/TO to stand for what? Shut down of operating controls. Step 3, turning off the machine at the operating control. This is where you need to understand the machine, and this is why it needs to be authorized, and you need to understand the energy, because a lot of times you just can't go and do shut down a machine. You have to do it in the correct order, or you might cause other things to happen, right? Shutting down the machine at the operating control does not bring the machine to a zero energy state. So that's just going over there and hitting the stop buttons on these machines, right? That doesn't bring it to a zero energy state. All that does is just shut the machine down to get it ready to be locked. Everybody okay? Isolating all energy sources. I've shut down the operating control. Complete all energy sources must be isolated as close to the source as possible. This means taking steps to make sure energy has no way to reach the machine or equipment. So this is where we would shut off the disconnects. We would shut off the disconnects on our, we usually call them disconnects. A disconnect is not a push button, right? You understand? A disconnect is going to be something that's lockable. It is actually at the source of the energy. Everybody understand that? Now, don't mean, that might not be misleading. It's at the source of the energy for that device. So we're not saying if you're out there working on a plant, you need to shut down the electricity to the plant, right? You understand? You need to shut down the electricity at the device and pneumatics and the fluid. So what you'll find out is just about every one of these things has a cutoff, some type of disconnect at the units themselves. If they don't, then they're not very smart. But most of these industrial plants, they've been in business a long time and they understand. Many isolating devices are used depending on the type of energy. We have circuit breakers, we have disconnect switches, we have valves, we have blocks, we have blanks and blinds. And I don't know what a blind is, so don't answer. All I know is about a Venetian blind. Anybody know what a blind? And each energy source is isolated. As each energy source is isolated, a lot must be applied to the energy isolating device by authorized employees to prevent the operation. Everybody okay? And then 6, as the energy source is isolated and locked, a tag, it didn't say might be, it says what? Must be applied to the energy isolating device by the authorized employee. Let's say employers. Tags are important because they warn others not to move the energy isolating devices from the off position. When tags are used, they must include the name of the employee applying the tag. Are we okay? And of course, this is what they say. And this varies from place to place. Like I said, if we didn't put our supervisor, we put the shop we worked out of. We put the shop we worked out of. We did put the equipment being worked on, but we did put the line. Now the date and the names of the work involved. I think at U.S. Steel they don't even put the date anymore, right? So what did y'all have out there? You had a brass tag that had your. They had your employee ID, right?
There were several of them that had a lot of or a lock extension. A lot of the locks at U.S. Steel, had multiple locks on that allows us to put multiple locks.
Well, these are lock extenders. So what they would do, they would give us the ability to put multiple locks. Notice there are 6 holes. You would use 5. Why wouldn't you put a lock in the 6th? Because if we had another person that came in, then they would use another one of these. So we'd use 5 locks. And of course they make them bigger. These are just the ones that we have here. It's pretty obvious how they work. A lot of the disconnects out of US Steel had multiple locks on them, about 6 or so. And then and that covered most situations on the disconnects themselves. Are we okay? Never interfere with equipment or machinery that is tagged. If you find a tag laying on the floor, contact your supervisor. Which makes sense. Tags are usually made out of paper. You know what happens? People accidentally hit them and they'll tear off. When we worked out there, we had tags. We had paper tags. Release all stored energy and residual energy after lock that was placed on the main isolating device, all downstream energy. Downstream means between you and the disconnect, right? Between you and the machine. Release all down. The system reaches 0 energy state. Many methods exist for releasing residual energy. Residual leftover energy is not released, presents a safety hazard. Energy may be released by opening drains, relieving system pressure, blocking system from gravity. Robots. A lot of times when you're working on these robots, you're in there working on the motor, those robots are up in the air, and you get in there, what could happen? They could fall. So blocking tackles, they have different methods that you can do that. So that would be stored mechanical energy. People forget about stored mechanical energy for some reason. You got something up in the air, and the mechanics is holding it up there, right? You understand? And then you go out and you kill whatever the drive is for that, and that thing can fall. Huh? Yeah, I'm not going to tell you what I did on the big ABB. That's exactly what I did on that. So, yeah. So the big ABB, it's not a big one, but it's the biggest training robot that we have. It has a brake relief button on it. And the robot got jammed up, and I thought I could release the brakes and then pick it up, but that thing was heavy. And final step for maintenance. Of course, nobody was in there. Our servicing can be performed in verify that all steps have been followed and that all energy has been blocked out or dissipated. So just don't take for granted that what you did took out the power, right? You understand that? So you always verify with gauges, with vents, especially pneumatics. Just about every service unit has a little drain on the bottom of it that you can do. You can turn it. Air comes out of there, then you can not only turn it, but you can also bleed it with it, right? You understand? Pressure gauges. They put a lot of pressure gauges out there on pneumatic systems that you can verify. Of course, electrical, we verify that with what? With the right meter. Special situations sometimes call for different procedures. Follow that was already mentioned. No matter what the situation is important that you detect the potential hazard. And some machines, in rare cases, a machine or equipment is not able to be locked out due to its design. Tags must be used in these cases. Never interfere with a piece of equipment or machine that is what? Tag. And this is what we talked about way back in the first of the presentation. Some repetitive tasks may not require lockout tagout procedures if the proper safeguards are used. Sometimes tasks such as unjabbing, lubricating, cleaning may be done if the operator uses the proper tools and does not bypass the machine. So a lot of machines have guards on them. that prevents you from getting hurt, but it also, they allow you to do things like lubrication, right? Cleaning and that kind of stuff without the danger of being pulled into the machine or getting caught in the machine. Of course, some machine guards are, sometimes people take them off because they get in the way. If a machine needs to be energized to test or position, locking tags can be temporarily moved for energy isolating devices. The area should be cleared of all tools and materials before locks and tags are removed. After the procedure is completed, all systems must be energized and locked and tagged with fire. So what that means is you go out there and you got a big motor, and you go out there and you lock and tag and you jog the motor a little bit, and you get to some screws, and you can't get to the other ones until you do what? Until you move it a little more. But you need to be careful that nobody's still out there, right? An alternative example to a group lock situation is the use of a lock box. The box is the most often used during a shift change in workers when all employees. So what they're saying, and this happened at U.S. Steel every once in a while. So what they're saying is that you got another crew coming in, and you got your locks on there, and they're coming in, and they got to do what? Put their locks on there. So the correct procedure is you're supposed to be there to take your lock off, and then the other group comes in there and puts their lock on. And this is definitely where these lock boxes and these lock extenders come in. Contractors, outside contractors may have lockout tagout procedures that differ from your facilities. Before any work is done by the employer, and contractors must coordinate these procedures. A contractor's procedure must be as safe as the established at the facility. So it's saying if a contractor comes in, they got to meet your standard, right? They got to meet or exceed your lockout standard. Does that make sense? This is shift change. The system being worked on must remain lockout during a shift of personnel change. The person leaving the job site should not remove his or her lock until the arriving worker has locked out with their own lock. But when the maintenance or servicing is complete, steps must be taken to ensure the safety of others before locking tags are removed. Notify all employees. That's kind of strange right there. I guess what they meant was, could you imagine if Rosa getting over the PA system, fix it, take off my lock. Suppose this is like at U.S. Steel when I worked out there. There was 10,000 people working out there, and it was all over the place. So what I guess what this means is to what all employees involved, yeah, or where you're at, in the vicinity of what you're working on. You know, a lot of companies would be impossible to notify what all employees. Clear away all tools and other items from machines and equipment, and reattach all your safeguards. Follow procedures to remove your lock and tag. So this is where you need to understand some systems have ways that you have to enter. This is why you got to be familiar with the system, because you take off your lock, and they might have a procedure on the way you should do what. You should reapply those energy sources. A study by the National Institute of Occupational Safety and Health found that 60% of workers injured by the release of hazardous energy were workers that were not authorized to perform lockout tagout. Yeah, I think that's it, guys. It says they was not considered to be authorized person. They were not authorized to do what they were doing. Right? You understand? So they didn't have the knowledge required to even be in there working on the equipment they have. Now, one thing that this PowerPoint leaves out, of course, is Who removes the lock? The person that put it on it, right? So that's a big problem. It's people, and that's why we don't use combination locks. Now these keys, the keys that you're going to use are going to stay here, right? So y'all don't take my keys. This is a little unique situation. And then of course, we have 2 keys per lock. Normally you only have 1 key per lock. And like I said, the bosses at US Steel had our other key, but they kept that in a locked cabinet in itself. And they only had the key there. So I didn't see much different between that and getting permission to cut the lock off. To me, having that extra key, as long as it's guarded, in some places you might go to work. I don't know what Rose's policy is on that second key, but anyway, I guess y'all find out. If y'all had to do any lockout tagout.
Everybody has a lock. So, where that majority is like preventive maintenance.
Preventive maintenance or actually true repair.
Yeah.
So a lot of your stuff is not really repair.
On the go.
Yeah, on the go, like jam parts and stuff like that. And a lot of, especially when you get into automated systems or robots, is those things are inside cages, and as soon as you open up the cage, they go to a safe position, you know. And so there's a lot of things you can do, and that's what they were talking about there. It doesn't say you can't work on equipment or do basic maintenance or stuff like that. It just says, you know, if you're going to actually get in there and start doing one. So if you're just going to go in there and replace a motor on one of your robots, you would lock and tag it. If you're going to go in there and clean up a jammed part or replace the tip on a welder, which is that's considered preventive maintenance. As soon as you go into a robot work sale, then the robot basically stops and it cannot move as long as the safeguards are in place. So there are extenuations, and that's what this PowerPoint brought up about that. So are you okay? Okay, guys, y'all take a 10-minute break, and I'll go get the lab. Our first lab is lockout tagout, and of course we'll be locking out the Amatrol line.